Okay, so if we look at the first one, is that a GCF or a slide divide problem? That's a GCF. What's the GCF? 5. You can take 5 out of 5, take 5 out of 60, take 5 out of 180. When you do that, it's a k-squared all by itself, which means it's no longer a slide divide problem. You take out the 5, you make it so it's one of the easier trinomials. So this is a GCF. Okay? Number 2, slide divide. 7 does not divide out of 18. It does not divide out of 40. So this is a slide divide problem. You can't get away from it. Okay? Number 3. Slide divide. 4 does not go into 9. It does go into 28, but it does not go into 9. So this is a slide divide problem. All right, 4. GCF. All of these are even numbers, so you can take 2 out of all 3 of them. 56? 56. The next one, number 5. GCF. 6 goes into 6, 6 goes into 12. I'm assuming 6 goes into 480.
Yeah.
Okay. And then last, slide divide. Why does what? Oh. It is possible. So I made it so these were one or the other. I made it so they either had a GCF that came out and then it made it so it wasn't slide divide, or it was slide divide. It is possible that we could write one where you take out a GCF and it leaves you with something that is still a slide divide problem. That's possible. I just wanted to give you guys a set of problems where it was one or the other. If you were to use the slide divide bottoms up method on a GCF problem, you would get the answer wrong. So that's really important for you guys to be able to recognize, oh, I should take a GCF out and do it the easy way. Because if you don't take the GCF out, you are going to mess up the problem. It's not a big mistake, but it is a mistake. You'll end up with your numbers being off a little bit at the very end. And it will be that at the very end, you will not have a GCF. So that's what the issue will be. Okay, let's pick one of the slide divide problems to do. So do you want to do 2, 3, or 6? 3. Let's do number 3. So number 3, 4x squared minus 9x minus 28. And so what is our first step? Slide. So we're going to take the 4, we're going to slide it over to the negative 28. Yeah, we're just going to make sure that we're good from yesterday, that we remember how to do these problems. So yes, you could do this. You could do this on your notes page, or you could do this on the warm-up page. It doesn't matter to me. Whichever page you do it on is fine. So 4 times negative 28 is what? 112? Is that what you said? Negative 112? Okay. And then when we do that in the calculator, we're going to be looking for something that multiplies to negative 112 and adds to negative 9. And I do not have that in my head as far as what multiplies to negative 112. So I'm going to press y equals, and I'm going to clear whatever the last class was doing in there. Like clear the whole memory. Second plus 712. So negative 112 divided by x. And then second graph. Anyone know what the numbers are? Negative 16 and 7. Okay, so we're going to write x minus 16, x plus 7. Okay, and then what should we do? Before bottoms up, divide by 4. Okay. Before that, simplify. Okay, so 16 over 4 is 4, and then we Bottoms up. Okay. So 4x plus 7. Perfect. Okay. Now go ahead and switch over to your notes. We have one more type of factoring we need to make sure that we know how to do. One more type.
How much are we writing?
Not a ton.
Can you take like a fourth of the page?
You could fit it in a fourth of a page, yeah. So one more type of factoring. You could get out a new sheet of paper. You could add it to your other notes. This is our fourth type of factoring. Fourth type of factoring. So either adding to your other notes or getting out a new page. This type of factoring that we're going over today is called difference of squares. Difference of squares. All right, so with difference of square problems, I'm going to go ahead and write out kind of like the formula that we use, but you're not going to really need to use the formula. These are pretty simple. So a squared minus b squared is what the problem looks like. You're going to see something, a perfect square minus another perfect square. Typically, one of the terms is x squared, or it might have a number in front of it. And then one of the other terms is going to be a perfect square. So like 1 squared equals 1, that's a perfect square. In fact, let's write this off to the side. So 1 squared equals 1, so 1 is a perfect square. 4 is a perfect square. 9 is a perfect square. 16 is a perfect square. What's the next one? 25 is a perfect square. What's the next one? 36. What's the next one? 49. 64. 81. 100. Okay. And then they keep going, right? We've got like 121, 144, 169. I think 196. Is 14 squared? 225. But these are like the recognizable ones. So when you do difference of squares, you'll typically have one of these numbers in the problem unless it's a problem that had a GCF first. And you had to take the GCF out before you could see one of these recognizable numbers. So difference of squares, when you factor it, you get 2 sets of parentheses. You get 1 with a plus and 1 with a minus. So a plus b, a minus b. So if the perfect squares are what you start with, then when you write it as the factors, it's kind of like you've taken the square roots of those perfect squares. So let's go ahead and do a few examples. Let's say we had x squared minus 25. Then if we factored that, we would just get x plus 5, x minus 5. So the square root of x squared is just x, so you get an x and an x. The square root of 25 is 5 and 5. This is called difference of squares, not sum of squares. So when we say difference, we mean in the math definition, difference means minus. So it has to be a minus sign. If it was a squared plus b squared, there's nothing you can do. If it said x squared plus 25, I would stop. I wouldn't even try to factor it because it cannot factor. It has to be a minus. So let's try factoring with 2 numbers in there. Let's say we had 36x squared plus, sorry, not plus, minus 49. So the square root of 36 is just 6. So we would have 6x, and then the square root of 49 is 7. So 6x plus 7, 6x minus 7. I think the ones that throw students off a little bit are ones where it looks like both of the numbers are perfect squares, but you actually need to take out a GCF. So let's say you had like 4m squared minus 100. 4 and 100, those are both perfect squares. So you would be like, oh, perfect. I can just do like 2m plus 10, 2m minus 10, but you cannot. Because if you look at this, you actually have a GCF in this problem. So what's the GCF? Bigger than 2? 4. You actually have to take out the 4 before you get started. Yeah, so it seems like you could just leave this and do the difference of squares as you begin the problem, but you can't. You would technically not be factoring correctly. So most instructions, when they ask you to factor, they would say something like, completely factor the problem. So if you were to start this problem, and we're all going to write this in our notes off to the side, we're going to show the wrong factoring. If you did 2m plus 10 and 2m minus 10, you can see that this factorization right here, this factor has a 2 in common. Everyone see that? It's got a 2 in common. So does this factor. So that means that we have a GCF in our first factor, we have a GCF in our second factor. That means that it's not factored completely. So while we factored it, we just didn't do a great job. In most instructions, they wouldn't just say factor typically, they would say factor completely, because they would recognize that while you kind of did what they asked, you didn't do a very good job. Does that make sense, the difference? So instead of doing, oh, I see a perfect square here and a perfect square here, I actually have to take out that GCF of 4, and then I get m squared minus 25, which is actually a different perfect square altogether. And then once I've taken out the GCF, now I can go ahead and do the problem. So now I'm going to say 4m plus 5, m minus 5. And that is actually the same answer you would have gotten if you took these first set of parentheses and took out a GCF of 2, took the second set of parentheses, took out another GCF of 2, multiplied your two GCFs together to get 4. But it's easier to do it this way. Does that make sense? So we always take out the GCF first, or else the math people get mad at us. Okay. How do we feel about difference of squares? Does that kind of make sense? Yeah. We can do those? Okay. Let me give you a few problems to try. This is not completing the square, but it should feel familiar because you did have a lot of perfect square numbers in there. Yeah, should feel similar. Okay, so let's do... Actually, I'll put... No. So when you check your answers, it doesn't matter which order you put them in. If you have your minus version first, that's fine. Not an issue. You're good. All right. We're going to move on to solving now. We're going to still be factoring, but we're going to be solving by factoring. So still in your notes, or if you want to start a new page since we're starting a new concept, that's fine. We're going to be factoring to solve. That's going to be the title of this part of the notes. So factoring to solve. Factoring to solve. So we're still factoring, we're just actually solving now. So we're going to have equations. Before we had expressions, now we're going to have equations. We're going to have an equal sign. We're not just going to put our stuff in parentheses in the factored form and stop. We're going to keep going to the end, and we're going to say what x equals. That's going to be the goal this time. So we're going to take it a step further. So before we get into the quadratics part, I'm just going to make sure that we're comfortable with actually solving the different pieces. So when you actually get to the solving portion, you might have something like x plus 5 equals 0. You might have something like 3x plus 4 equals 0. You might have something like negative 2x equals 0. And I just want to make sure that we're comfortable solving all these different things because these are all the different pieces that when we are factoring and solving, we're going to end up solving all these different pieces at some point. So if I needed in this first equation, if I needed to get x alone, how would I do that? I would subtract the 5 over to the other side. And I would get x equals negative 5. Okay. For the next one, and I'm going to wait just a second, okay, for the bathroom. For the next one, if I want to get the x alone, what would I do? I would minus the 4 first. I would get 3x equals negative 4. And then what would I do? Divide by 3. And I would get x equals a fraction, and that fraction would be negative 4/3. Yep, this is not new yet. Yeah. And then over here, if I wanted to solve for x, what would I do? Divide by negative 2. And 0 divided by a number is 0. 0 divided by a number is 0. That's okay? It's a good brain fart moment. Okay. So these are all the different things that when we factor, these are what our factors might look like. And so when we're factoring to solve, these are the different pieces that might help us to solve. Okay? So these are what our answers are going to come from. All right, so let's go ahead and take an equation and start to solve it. So let's say we had the equation x squared. This is going to be our example problem. X squared plus 9x plus 2 equals negative 6. And you might remember this from Mr. Fulton, maybe. When you are factoring to solve or when you're doing the quadratic formula to solve, the equation is not allowed to equal negative 6. It has to equal something specific. It has to equal 0. Yeah. I have to add the 6 over. It has to equal 0. So I'm making it equal 0 right here. So I've got x squared plus 9x plus 8 equals 0. And then from there, I just want to figure out what type of quadratic I have so that I know how to factor it. So this has 3 terms right here. The first term does not have a number in front of it. So it's a trinomial, no number in the front. And what type of factoring is that? Does it have a number in each of those that I could take out? Does it have GCF? No, so it's not a GCF. Is it a slide divide? Does it have a number in the front? No. So it's just the normal type of factoring. We do the little X thing. We look for what multiplies to 8 and adds to 9. Okay, so what are the numbers that multiply to 8 but add to 9? My 6 was over here. I added it to the other side because I wanted it to equal 0. So I combined my like terms. 8 and 1. So the 2 numbers that multiply to 8 but add to 9 are 8 and 1. 8 times 1 is 8. 8 plus 1 is 9. Are we good so far? Okay. So I'm going to write my parentheses, x plus 8, x plus 1. And that also equals 0 because I've just taken the quadratic and I factored it. Okay? Now, this is what this is what Mr. Fulton called the zero product property. If this represents one number and this represents another number, when I multiply 2 numbers together and I get 0 as an answer, that means that something had to equal 0, right? If 2 numbers multiply together to be 0, something had to be 0 to get that as an answer. So one option is that x plus 8 could have represented the number that equaled 0, so that you did 0 times something equals 0. Or the other option was that this number represented something that equaled 0. We're not sure which one it was. We just know that whatever value we plugged in for x, something zeroed out. Yep, that's what it means when we're solving. So I'm going to take each different piece and I'm going to set them equal to 0. And then we already know how to solve this. We verified that's something that we learned how to do before in math when we were younger. So I'm just going to take that. I'm going to get the x alone by subtracting the 8 over. I'll get x alone by subtracting the 1 over. And so what are my 2 solutions? -8, -1. And a lot of people do not like to show their work for this. They get the 2 factors, and then they say, if this is positive 8, my answer is -8. If this is positive 1, my answer is -1. You can do that. This is just where it comes from. No, you can do it. Well, that's fine. Okay, let's try another one. All right. X squared equals -12x minus 32. Now, this is something that came up on the day where we were learning about quadratic formula with Mr. Fulton. And I was trying to really focus, help you guys figure this out. I was writing it on the board repeatedly and writing stuff up here and like trying to mime to you guys. But whenever we do problems, we always want the x squared term, we want it to be positive. So when we got to the quadratic formula, what we learned was that sometimes you're solving a quadratic and you cannot factor it. And if you can't factor it, then you'll just use the quadratic formula instead. But you don't always know that from the beginning of the problem that it's not factorable. Sometimes you try to factor it and then you realize like halfway through like, oh, I can't find the numbers that do this. I can't find the numbers that multiply to something and add to something. So because we don't know that we're going to use the quadratic formula at the very beginning of the problem, we always pretend that we're going to factor. And factoring is always easiest if the x squared term is positive. So that means we're going to take the 12, we're going to move it over, we're going to take the 32, we're going to move it over. We're always going to have the x squared term be positive because it is easiest to do the problem that way, okay? I'm not saying that to make your life harder, I'm saying that to make your life easier, okay? I promise it makes it easier. So I'm going to add the 12x over, and I'm going to add the 32 over. If you do not do that, then you end up having to take a GCF of -1 out of the problem before you get started, and most students forget to do that. And then most students get the answers wrong. So if we want to avoid that completely, just make the x squared positive every time and you'll get it right every time. Okay, so what do we have? Okay, so this is a trinomial. It's a trinomial. Is it one of the easy ones or is it a slide divide? Wait, is it a slide? It's one of the easy ones. We're multiplying to 32. We're adding to 12. What are the numbers? 8 and 4. So we have x plus 8 times x plus 4. And so what are the two solutions? -8 and -4. Okay. Let me write down your homework. Homework? Yeah.